Welcome, I'm Tim Hales. In this, the fourth of our series of 6 training videos, I will explain how to set up our Intero guidance on a new machine and how to do initial field runs. So let's get started. First, you need to mount the components onto the implement and tractor. Pay particular attention to ensuring that the camera is mounted rigidly onto the frame with provision for height and inclination adjustment. Whilst not essential, it is much simpler if the camera pole is arranged to be square to the frame so that the pole is vertical when the implement is horizontal. For mounting consoles, we recommend RAM mounts as they are easy to use and provide a degree of electrical and vibration isolation. Check that any sensors fitted trigger with appropriate movement, especially lift sensors, which can, if not fitted correctly, produce spurious lift signals interrupting vision guidance as the wheel ruts are traversed. If this is difficult to achieve, consider an alternative mounting position or use the tractor's 7-pin ISO socket to provide the lift and speed signals. Our cables come in varying lengths, so it should always be possible to specify cable runs that avoid trip points or coils of excess cable. Now we will power up for the first time. Connect both 12-volt power and hydraulics. Press and hold the power up button for a second or two until it stays illuminated, then wait for the home screen to appear. From the home screen, navigate to the setup screen via the working screen. On the second line down, select the configuration most appropriate to the machine geometry and crop row spacing. Return to the working screen. Lift the implement, checking that the lift symbol appears on the screen. When it is safe, turn the tractor hydraulics on, preferably with a low flow set. If you lower and then raise the implement, it should automatically centralize the side shift or steering discs. At this stage, it is a good idea to do a steering test. This slide gives the procedure for on and off directional steering valves. With the implement lifted, from the working screen, press the top right spanner button to get to the setup screen. Then press it again, this time marked spanner ++ to get to the advanced settings and diagnostics screen. Turn hydraulics on. Select steering test and respond to the on-screen prompts, remembering that left and right are defined as when looking forward in the direction of travel. The test may give you fault messages which you should respond with an appropriate adjustment. For example, if you get the message too fast, you need to reduce oil flow rate to the cylinder. If you get too slow, increase oil flow. If it says hit stop, check the position sensor is central and its stroke matches the figure in the configuration. You can also exercise side shift or steering discs by entering manual mode from the working screen and pressing left or right arrow keys. Each time you press an arrow key, a side shift will move 7% of its stroke. If you keep pressing the same key in quick succession, you can get a continuous movement. A typical steering rate for a side shift would be approximately 10 centimeters per second. A typical disc steering rate would be approximately 5 degrees per second. Now let's consider the same procedure for a proportional valve. The test is entered in exactly the same way. The system should already know that the proportional valve is fitted because the switch on the microcontroller in the implement module will be set. It will therefore automatically follow the appropriate procedure. The proportional valve steering test starts in the same way and will require you to confirm direction of travel. However, having established the correct direction of travel, the system will automatically go on to make additional full stroke movements to calibrate speed. Like the non-proportional steering test, you may be given warnings which might have slightly different implications for a system fitted with proportional valves. For example, too slow may indicate the valve fitted does not have the flow capacity to drive the cylinder at the required rate. Once the steering test has passed, you can proceed to setting up the camera. We are going to cover two ways of setting cameras up. The one covered in the slide is done purely by measurement and does not require crop rows. The second, covered in subsequent slides, allows you to visually match the crop rows, real or artificial, to the computer's template. Both should yield the same result. So let's look at the purely measurement technique now. The first step is to go to the setup screen and ensure you have selected the appropriate configuration for your machine and its intended crop. You should also make sure the fine offset is central with 0 offset. Make a note of the camera height and the look ahead from the figures displayed on the bottom left of the setup screen. Physically adjust camera height on the pole to match that figure. Remember that height is measured from the soil level, so you may have to make some allowance for that if working on a concrete factory floor. For best accuracy, camera measurements should be made from the centre of the lens, which is about level with the back of the camera turret. Next, place a marker on the ground vertically under the camera. Measure forward from that marker by the look ahead distance and place another marker on the ground. A spanner is our traditional marker. Set the console working screen to manual mode and you should see the blue crosshairs have been superimposed over the live video image. Adjust camera inclination angle until the centre of these crosshairs coincide with the look ahead marker. Tighten screws. The camera should now be set up. You will have to repeat that for any other cameras fitted. If you want to double check you have got this right, you can put some green tape on the floor and follow the by eye setup technique covered in the slide after the next one. We will now consider a situation in which none of the configuration options you already have stored as presets are appropriate for the machine you have now. The first step is to physically set the camera to the desired field of view. Measure the new camera height and make a note of it. Next, place a marker on the ground immediately under the camera. Enter the working screen and select manual guidance mode to get the blue crosshairs up over the live video image. Place a marker on the ground to line up with the blue crosshairs. Then measure the distance between the markers, which is the new look ahead distance. Make a note of that too. If you already know how to do this, open the configuration editor, copy a current configuration and edit the copy to include the new camera parameters. Name new configuration so the user will recognize it. If you do not know how to use the configuration editor, you can learn how by watching video number 6 of this series of presentations. Alternatively, it is also covered in the reference manual and our video tutorial on the subject. Again, if you want to double check your new configuration and setup, you can mark green lines on the floor and follow the by eye setup procedure to ensure everything is correct. Now going back to the situation where we already have a good configuration and just need to set the camera up to match the preset values. This alternative camera setup option requires crop rows. These might be real crop rows in a field, or they might be artificial crop rows created by placing green tape on a factory floor. As before, we need to open the setup page to check we have an appropriate configuration selected and the crop height setting matches the crop we're in. Remember that if we are doing this in the factory, looking at lines of green tape on the floor, crop size should be small. For this procedure, we do not need to know look ahead, but we need to make a note of the camera height. Set the machine into the field so there's a normal working level and the camera pole is vertical. Position the camera over or between the appropriate rows. Adjust the camera height to approximately the same as the value in the selected configuration. Enter the working screen and enter manual mode. If the green template lines do not appear central and symmetrical, reset the camera skew from the Advanced Diagnostics and Setup page, then return to the working screen. Adjust the camera inclination angle until the green template lines lie over or parallel to the real crop rows as they appear in the live video image. With a small, newly emerged crop, you may find it difficult to see the real crop rows. Touch on the main display to get into full screen mode. This should help a bit. But if the crop rows are still not clear, you can lay visual markers on the ground over the crop rows to make this task easier. If the template lines are all parallel but laterally offset from the real rows, you need to slide the camera laterally until they do line up. If the green template lines match up with the real crop rows in the image like this, then the camera is correctly set up. However, if it looks like this, it is worth making some adjustments to improve the fit in order to achieve better performance. In this case, point the camera upwards to a more shallow angle until you get alignment. If it is not possible to move the camera far enough to get the desired alignment, you might need to make a note of the camera height and look ahead you can achieve and create a new configuration based on those parameters. This is a similar situation, but the other way round. In this case, it looks like you should point the camera downwards to a steeper angle until you get alignment. Hopefully that is possible, but again, if not, make a note of the camera height and look ahead you can achieve and create a new configuration with those parameters. Hopefully we now have a view that looks a bit like this. However, as we only set camera height proximally, and if the view looks something like this, it may be that the camera height also needs adjusting. In this case, the camera looks to be too low. Before we move the camera up, there are another couple of parameters that need double checking. First, check that the crop size setting selected on the setup page is appropriate for the crop in view. If not, change the selection and try again. If you still do not have a good match, check that the row spacing you have in the field matches the figure displayed on the bottom left of the setup screen. If not, you should either select a configuration with the correct row spacing, or if you do not have one, create a new one. If the difference between the actual row spacing and the configuration value is small, it is possible to fool the system by simply moving the camera up or down until the template lines are in alignment with the crop. In most situations this will work. However, there are two reasons why you may want to get the figures right. First is that it may cause confusion with future users and technicians who are not aware of the history. Second, that if the machine is obtaining speed using our visual odometry, it will be given an incorrect speed figure if the geometry is not the same as those used for its calculations. If the difference is small, the speed error will also be small. In this case, it looks like we need to move the camera down for a good template match. Though, as we have just discussed, it might be worth checking crop size and row width figures to check that they have been correctly set. So hopefully you will end up with a template match that looks like this one. Accurate template matches make a big difference to reliability when conditions get difficult, so it is worth spending time to get this right. Whilst we're discussing templates, it's worth mentioning the special case of following a single row. Following a single row has the disadvantage of being vulnerable to areas of high weed infestation or poor emergence, as the template is only matched over a small area, providing limited redundancy. However, it does have a great advantage that a single template line will always match single crop row. They will always both be straight up the middle. Incidentally, the same is true of the central row when following an odd number of rows. For that reason, following 3 rows is much better than following 2. As aside from having 50% more data, you are also guaranteed a perfect template match for the central row, making it a bit more forgiving. If you're using visual odometry, you will still need the camera height to be at least approximately correct for good speed estimate. Strangely perhaps, the row width figure does have some significance when following a single row. It should be set 2 to 3 times the crop plant foliage width, or a minimum of 20 centimeters. If you are following a single row, reliability can be significantly improved by adding a second camera. So whatever your setup and whatever the procedure you used, when it is all done, remember to tighten the bolts. If you go into vision guidance mode now, all the green template lines should align perfectly with the real crop rows, and there should be a line of blue crosses vertically up the centre of the image. If you have multiple cameras, you will have to repeat this for all the others, but otherwise you are ready to go. Remember, not all cameras have to be set the same. You might set up cameras differently on the same machine for a variety of reasons. One might be that you want to leave the user with one setup they can run all season with no changes. So for example, you could set up one camera to be optimal for early growth stages, generally a shallow inclination with a longer look ahead viewing plant stems more side on, and another for later stages with a more vertical plan view allows you to see the soil between the large crop plants. In that case, all the user would have to do is adjust the crop height settings as the season progressed and still get good early and late season performance without having to physically change anything. Now you have a good template match, it is time to get running in the field. Before setting off, it is worth making a few basic mechanical checks. For example, that the hoe blades are accurately spaced between the rows. It is probably also worth doing a final check that the steering is working. With the implement lifted, use the manual button to check the side shift is moving smoothly and in the correct direction. Remember that the side shift mechanism requires a rigid point to push against. For smaller implements mounted on relatively large tractors, it might be okay to simply tighten the 3-point linkage check chains, but for larger implements, stabilizer disc or something similar will be required. Ensure that the top link length is set correctly so that the camera pole is vertical. In the past, many experienced hoe operators may have used top link length for cultivation depth adjustment. This disrupts camera guidance, so they may have to be briefed to use alternative methods to adjust depth. Depending on your confidence levels and the value of your test crop, you may wish to remove or raise blades out of the soil to minimize any crop damage during the initial learning phase. Align the implement with the crop rows as you lower it into the crop. Do one final check for template match. If it is good, set off slowly. Vision guidance will start working immediately. However, for the first 100 meters or so, it is learning the camera skew angle, and for multiple camera systems, also learns camera offset. For this to work at its best, the crop rows need to be clear and dominant, and the field should be relatively flat. You may find that you have to adjust the fine offset as the camera skew and the offset parameters are learned. After 100 meters or less, the camera skew should have stabilized. It should settle to a value less than 3 degrees. Fine offset will probably not be central. So it is good practice to centralize that by moving the camera laterally by 1 centimeter per tick of offset. Working out the direction is the challenge. You could try thinking of the camera as locked over the rows and moving the machine to compensate for any error. So, for example, if the machine runs to the left requiring 3 ticks of right fine offset to compensate, then the camera should be moved left by 3 centimeters. If 2 cameras are fitted, you should try to move both the same amount. If a mechanical clash prevents you moving the second camera exactly where you want it, get it as close as possible and reset camera offset so that next time you run, the system can learn the new offset value. Having done that, the machine is now set up for accurate inter-row cultivation. Just one final point. Unless camera orientation in the yaw plane is changed, camera skew should not be routinely reset to 0. After every reset, a further learning run on an easy crop is required before full performance is restored. We hope you have found this presentation useful. Remember that this is the 4th of a series of 6 videos that you can select from on our website and view them as many times as you want. Our website also has links to other reference and training material, including reference manuals in French, Spanish and German languages. If you have any questions, please get in touch, and thanks for watching.